Hello and welcome to another video in the Chemical Kinetics and Equilibrium discussion series. For this video, we will be discussing Le Chatelier's principle. So when we talk about Le Chatelier's principle, what happens when a reaction is at equilibrium and something changes? For example, what happens when the temperature is increased or some additional reactant is added? So Le Chatelier's principle is a general rule used to explain the effect of a change in reaction conditions on equilibrium. So Le Chatelier's principle states that if a chemical system at equilibrium is disturbed or stressed, the system will react in a direction that counteracts the disturbance or relieves the stress. Some of the possible disturbances would be concentration changes, temperature changes, and pressure changes. For the first one, we have the concentration changes. So consider the reaction of carbon monoxide with oxygen to form carbon dioxide. What happens if carbon monoxide is increased? If the reactants and products are at equilibrium, what happens if the concentration of carbon monoxide is increased? Now, the equilibrium is disturbed and as a result, the rate of the forward reaction increases to produce more carbon dioxide. We can think of added reactant as driving the equilibrium to the right. When the system reaches equilibrium once again, the concentrations of carbon dioxide and carbon monoxide are both higher. Since oxygen reacted with the additional carbon monoxide, its mu value at equilibrium is lower. Even though the concentrations of reactants and products are different, the value of K is the same. So remember, if we increase the concentration of carbon monoxide here, the concentration of oxygen will decrease and the concentration of carbon dioxide will increase. Now, what happens if carbon dioxide is increased? Now, the equilibrium is disturbed but there is more product than there should be. As a result, the rate of the reverse reaction increases to produce more of both reactants, carbon monoxide and oxygen. We can think of added product as driving an equilibrium to the left. So when the system reaches equilibrium once again, the concentration of carbon monoxide, oxygen, and carbon dioxide are all higher. Even though the concentrations of reactants and products are different, the value of K is the same. Similar arguments can be made about the effect of decreasing the concentration of a reactant or product. Sometimes, when K is less than 1 and the amount of product at equilibrium is not high, a product is removed from the reaction mixture as it is formed. For example, ethanol can be converted to ethylene and water in the presence of a small amount of acid, but if equilibrium does not favor the products. In this case, water can be removed from the reaction as it is formed. A decrease in concentration of one product results in more of the forward reaction to more product. This process drives the equilibrium to the right. If the water is continuously removed, essentially all of the starting material can be converted to product. So remember, when we remove a product here, it will drive the reaction to the right, therefore increasing the concentration of ethanol and increasing the concentration of the other product, which is ethane. Now, in order to predict what effect a change of temperature has on a reaction, we must know if a reaction is endothermic or exothermic. So when the temperature is increased, the reaction that absorbs heat is favored. For example, the reaction of nitrogen and oxygen to form nitrogen monoxide is an endothermic reaction. There is a positive 43 kilocalories per mole of delta H. Since an endothermic reaction absorbs heat, increasing the temperature increases the rate of the forward reaction to form more product. The equilibrium shifts to the right. Remember, an endothermic reaction absorbs heat, so increasing the temperature favors the forward reaction. Now, if there is an exothermic reaction of nitrogen and hydrogen to form ammonia, which has a delta H of negative 22 kilocalories per mole, increasing the temperature increases the rate of the reverse reaction to form more reactants. So when temperature is increased, the reaction that absorbs heat in this case is the reverse reaction. Predominates and the equilibrium shifts to the left. Remember that an exothermic reaction releases heat, so increasing temperature favors the reverse reaction. Conversely, when the temperature is decreased, the reaction that adds heat is favored. In terms of the pressure changes, when pressure increases, equilibrium shifts in the direction that decreases the number of moles in order to decrease pressure. So when substances involved in a reaction are gases, and the number of moles of reactants and products differs, a change in pressure has an effect on equilibrium. So in an example here, in the reaction of nitrogen and hydrogen to form ammonia, there are 4 moles of reactants but only 2 moles of the product. So when the pressure of the system is increased, the equilibrium shifts to the right since there are fewer moles of the product. Whereas when pressure decreases, equilibrium shifts in the direction that increases the number of moles in order to increase pressure. In contrast, when the pressure of the system is decreased, the equilibrium will shift to the left since there are more moles of reactants. So here is a table summarizing the effects of changes in conditions on equilibrium. Again, we have concentration, temperature, and pressure. And that's the end of our chemical kinetics and equilibrium discussion series. Thank you for listening.